Very glad to have Dr. Bill Robertson join us from California. He's at California Air Resource Board. He's the vehicle program specialist, and he's back to speak to us. We're very glad to have him give us an update on how things are evolving in California. We'll talk more about low NOx regulation and where that's heading, and we look forward to hearing from Bill's perspectives in terms of how California is moving that ahead. Bill himself is, he's the vehicle program specialist for heavy duty. His experience includes diverse projects including quantifying criteria and toxic emissions, also fuel efficiency, plus evaluating alternative fuels and after-treatment technologies for heavy duty. So a wide range of experience. He's been with the board for 12 years. He's got a background in chemistry from Andrews University and a PhD in physical chemistry from Yale, and a postdoc at the University of California, Irvine. So very well experienced in terms of the technical side of this, but also driving some of the legislative developments. So Bill, thank you for joining us here in Pittsburgh, and we look forward to hearing your presentation. The floor is yours.
Thank you, Tim, and to Integer in general for providing this venue and bringing us together, and bring greetings from California, and hopefully I can give some perspective on some activity we have going on and what our vision is in this heavy-duty area. This year's kind of a big year for us. We have our 50th anniversary this year. Ronald Reagan, half a century ago, signed the legislation forming our board, and we've had quite a history since then in defining tailpipe standards and bringing new technology into the light-duty industry, and working with our federal partners on the creation of heavy-duty standards, which then have more recently moved into fuel economy and climate change sorts of activities. So our twin missions of the criteria pollutants back from our inception, and in the last 10 or 15 years on climate change, we've been receiving direction from our legislature recently to really look at those programs and make sure that our investments that we're making in each of those areas really affect all of the communities in California, and especially the disadvantaged and disproportionately polluted areas of our state. So that this Senate Bill 617 is directing us to look at community toxics exposures and how goods movement affects particular neighborhoods and those kinds of things. So that's a new direction for us moving into the next half century of our existence. They were also nice enough to not just give us directive as to how to do our job, but they're also giving us resources. We broke ground about a week and a half ago on a new Southern California headquarters, which is going to be it's a $419 million project. We're have the goals of LEED Platinum and zero net energy for this engineering test and chemistry laboratory facility. And it's going to be a large expansion of our heavy-duty capability. We're going to have 3 chassis dynamometers and a couple of engine dynamometers and a bunch of workshop space to support our field activities, whether that's PEMS or looking at whether parts are detected with OBD systems or whatnot, but really getting out into the field and operating these vehicles and seeing how they behave. So we're very excited about this. It's going to be about a 3-year process to get the facility built and outfitted. So we've had historically a lot of air quality issues in California. It's a great place to live. There are a lot of people there. We have a lot of resources, and then we also have geography that kind of holds all the emissions together. And so the Central Valley and the South Coast have these extreme non-attainment areas, and both the PM in the Central Valley and the ozone in the South Coast have a large NOx component to the issue. So our modelers are telling us we need 70% reduction by 2023 and 80% reduction by 2031 to bring these areas into attainment to meet the federal health-based ambient air quality standards. So those are economy-wide NOx reductions that we need, and there's parts of the NOx sources that are easier to make a change with than others. And so we're looking very carefully across the entire economy to where we can achieve these reductions. So this pie chart here shows a bunch of different categories of where the NOx in California comes from statewide. And I'm not expecting you to read all the little aircraft and stationary and ocean-going vessels and all these categories. But there's a third of that plot that's heavy vehicles. And so when we're looking for an economy-wide reduction of 70%, a category that includes a third of what's happening is definitely going to be an area we're going to look very carefully at, and we're going to need to make very large reductions to. So there's a different way of looking at the heavy-duty NOx emissions. This is from our IMFAC 2014 inventory tool, looking at the split between the pre-SCR vehicles and the post-SCR vehicles moving forward in fleet turnover, and then breaking out kind of where those SCR vehicles are projected to be giving their emissions. And we see that, currently it's all about fleet turnover and getting the older technology replaced with 2010 class and later vehicles. And we have fleet rules in place to do that that mature in about the next 5 years or so. And after that, we're projecting we're looking at other people's projections of economic growth, and even though the technology is much cleaner on a per vehicle basis, we see that creeping growth in there. So to actually get a 70 and 80% reduction going forward, we're going to have to do something to each of these categories of NOx emission we see from this technology. And there's the lower sort of 3 or 4 bars there are the as-designed emissions that a vehicle would have, on day one. And then there's the, what happens to the fleet emission rate as things wear, as individual vehicles have failures, and the frequency with which those get repaired and whatnot. There's that, you see that deterioration slab there is quite significant. And so we're going to have measures that look at durability as well as user responsibility in that mix. But even if we could completely fix deterioration, we still need to look at these emission rates in these other categories for further benefit to meet our NOx goals. So we haven't just been looking at our model. We've been going out in the field and collecting data. We have a contract with University of California, Riverside, CSERT, and they went out and put data loggers on 100 different vehicles and a dozen applications or so, and followed each of those vehicles for a month. And then we were looking, so what is the distribution of activity in these different vocations and whatnot. These are histograms in time of the temperature that we saw at the after treatment. I threw a blue vertical line at 250 degrees, figuring that any of your competitors should be able to get an SCR to work above 250. Yours probably works a little better below 250 for a certain measure, but pretty soon you have to start being creative and really thinking to make things work in that area. So we were a little surprised as to how many of the applications had 40–50% of the activity happening in this cooler area. And even for vehicles that were, they were saying, hey, we're a line haul operation, but evidently there's a certain amount of yard work and getting from the freeway to the facilities where they're actually making their deliveries. And California has a number of urbanized areas, so even for that, we're seeing quite a bit of activity that the current calibrations and designs interacting with the duty cycle are producing some significant cool operation. So we talked about this at Transportation Research Board in January, and there's a paper that you'll be able to get off the presentation materials afterwards, the link for it. But we've been continuing to look at this data set, and the temperature wasn't the only information we collected off of those vehicles. This is looking at the same data set, looking at the NOx sensor data, and taking all the time a given vehicle's NOx sensor was active over that month that we followed it, and just averaging what the mass emission rate was for that on a work-specific basis. Yeah, it was pretty interesting. We see about 10% of the vehicles were operating at a level commensurate with like a 0.2 FTP kind of level. We thought that was good, and those tended to be more of the line haul sort of applications in this data set. But we also saw some vehicles that were pretty consistently operating at quite high NOx, and so we think there's some area for improvement, and that our current program may not ask for quite as much calibration in that area as we'd be interested in, and there may be some technology shifts as well that could be very helpful there. So those two data sets were talking about looking at the low load, at the cooler end of things, but we're also interested in how vehicles are doing at high temperature. So we've been recruiting vehicles, in-use vehicles, and then loading them up and running them down the freeway on goods movement corridors towards Vegas, towards Phoenix. We run them out a half a day, we turn around and drive them back, and then we run that data through the standard NTE data workup process with all the exemptions and carve-outs and everything. And we have, of 22 trucks we've pulled in the last year and a half or two, we've seen 6 that produced acceptable pass ratios for the NTE events. So this is just looking at the NTE events for these vehicles. And then we've seen a couple of trucks that had 0 pass rate, and then quite a bit of performance in between those two extremes. So it's some work we're continuing to broaden, to make sure we have a range of vehicles that we've looked at. But we are very interested in how these vehicles operate. We were a little surprised by this data set because the heavy-duty in-use compliance program has been going for 10 years or so now, and I think identically one set of data has been turned in by a manufacturer that had a failing result. So there's a little bit of discrepancy between some of the ease with which the vehicles that we were able to recruit performed and how some of the reference vehicles turned in have been performing. So there's we have these very aggressive goals that have been given to us to reduce NOx. We've seen some interesting data in these studies and in other roadside measurements and whatnot. But we realize that we have to look at all the different pieces of the program together to achieve these very large reductions. So that's going to involve dealing with the in-use fleet. That's going to involve our side figuring out what the proper ask is up front for vehicles. That's looking at how the vehicles perform over time, and pushing for new technology and other sort of system level savings that we may be able to get. Tim had his politics slide. We've been working very hard with the federal government historically to develop heavy-duty emissions regulations and the more recent greenhouse gas regulations. We're on track to present to our board in February our version of the federal program that'll be aligned on structure, stringency, and timing. We're not going to do a deem to comply. There will be a California certification, and there'll be some differences to allow us to track the trucks that are coming into California, that are being sold into California. And we look to continue partnering as much as we can. We are pursuing a low NOx engine program, and part of that holistic view will be to have a new engine standard that for cleaner engines, some kind of upfront ask for the low load performance demonstration. We're thinking right now that could be a low load cycle, and we have some research going on to try and inform that with real data. And then an in-use emission standard, and I'll talk a little more about that a bit later, but we've been having a lot of interaction with the stakeholders individually and through the Engine Manufacturers Association, Truck and Engine Manufacturers Association. So we're looking to bring something to the board in 2019 for that larger package. As we've been working on this, we've been trying to set up to figure out the scoping of what a low NOx engine program should look like. Part of that was providing opportunity for people to bring technology forward and get some kind of credit for it or incentive funding or whatnot. So we've had this optional low NOx standard on the books for a number of years now, with 90, 75, and 50% below the current standards. And we're now up to about 10 engines certified under that regulation. I have a graph on that next. And then we also have looking at what can be done in the diesel arena for low NOx. And there was, unfortunately, the talk fell out that was going to have a lot of detail on that, but maybe I can give a bit of preview there. And Mike Geller is going to be talking about some of the technology options as well later on in the conference. So this chart shows the low NOx engines that are currently certified in California. Just showing the symbols show the displacement of the engines, and then the squares are showing which of the standards those engines certified to. And we're pretty excited that half of the engines already have been certifying to the most stringent of the optional standards. And then most of these are natural gas engines. There are a couple of propane in there. And then the red box is kind of the unique one. It's using these same stoichiometric three-way catalyst approaches with gasoline. And so there is a certified liquid fuel low NOx engine out there. And there was discussion of the low end of the market, the weight classes being less diesel dominated already, and there were some questions about what do we see in shifts and whatnot. So I think that's an interesting category to follow as you start pulling some of the direct injection out of the light duty side of things, and to get more diesel-like torque and have some options that can hit the low NOx without necessarily having the complexity of some of the other approaches that diesel may or may not eventually be the configuration that goes to market. So we've been putting our money behind trying to figure out what is a reasonable expectation for diesel technology in this space. And we have these health-based standards that we know what we need in NOx performance, but what can we actually make happen and have demonstrated? So we've been funding research at Southwest Research Institute, and the stage 1 contract, which is completed now, was targeting 0.02 grams brake horsepower hour NOx over the certification cycles using production intent parts on an unmodified engine, just the calibration adjustments, but the standard hard parts of the engine. We weren't changing turbos or anything. And there we were able to, with oven-aged parts, we were able to get below the 0.02. We did a full useful life thermal aging with 20-25% chemical aging. And those parts came back with a 0.035, which we thought was an enormous improvement over 0.2. But it was a little shy of our goal. But there was also some question mark over just exactly how final a number that was, because one of the catalyst substrates slipped in the can during the testing, and so there was some plugging of the matting material that caused some air fuel control issues until it was shut down and recanned and resolved. So despite having that issue that we weren't able to completely reset the aging within the funding of that contract and start over, but we're pretty excited about that level of improvement. MECA and the South Coast Air Quality Management District stepped up with funds and another set of parts, so we're going to be going back and taking a look at that number in more detail. And then we have a second extension into stage 2, where we take the calibration from stage 1 and that configuration, and we're trying to see how much we can do with calibration to get low load performance in NOx where the break point is of getting better performance. Where does it start to affect fuel economy? And then once it does affect fuel economy, what can we achieve beyond, what does that trade-off curve kind of look like down there in that area? So we think that area hasn't received quite as much calibration attention under the current regs, and so we're trying to explore that. Part of that exploration will be figuring out what kind of challenge scenarios to throw at the engine, and we have NREL looking at their fleet DNA database and some of the activity data that we've in California collected. And so they're doing a big data approach to coming up with candidate duty cycles to find some things that exist in real life to challenge these systems with down at that low end. And then we have the contract signed for a stage 3 on this low NOx diesel work, which is to do the certification cycles and the low load calibration work that was done in stage 1 and 2 on a second architecture. So our stage 1 engine, Volvo provided us a turbo compounded engine, so it was using a post-turbine waste heat recovery technology as part of the greenhouse gas compliance strategy. And so we're looking to have a contrasting architecture that takes a different approach and see how that greenhouse gas strategy decision-making process affects the complexity of the required NOx after treatment. Depending on how you do that, it can affect what the final exhaust temperature profile is and some of the energy requirements to keep a NOx system active. We also have our low NOx, our low carbon transportation investments program, which gets funded out of our cap and trade program. The money's from those carbon auctions. And we recently had an on-road advanced technology demo solicitation, and one of the proposals we received was for an opposed piston engine project with a low NOx after treatment thing. So I just throw that on there. We're still evaluating the applications, and you can see the one-pagers on our website of all the applications we received. But I just thought it was interesting. We have there's another group that's saying, hey, let's take a crack at this low NOx project for diesel, but specifically in a greenhouse gas improvement context. So we have a lot of work going on with initial engine design and how to control the NOx. We're interested in coming up with an in-use standard that covers much more of the vehicle operation than just fixed cycles do. We're very happy about the things that NTE has been able to accomplish. Of course, it came out of this consent decree that came out of some interesting business decisions that were made in the industry back in the late 90s. And so it was aimed kind of at that particular defeat device. But even in an application where one would think there would be a lot of NTE events with high load operation, high temperature operation, continuous operation, we see very little of the activity actually being falling into the viewable considerable part of the NTE procedure. Most of the data is just excluded. And so we're looking to take some of the measurement tools and these PIMS units that were created for that program and how can we use them across the entire vehicle operation in a way that makes sense and actually provides a good incentive to calibrating the full operation of these vehicles. We're also looking at how vehicles that go 500,000 miles, 1 million miles, how to encourage good designs and make sure that they're getting repaired with the proper parts and have longer durability. So one of the things we're considering is how long warranty coverage should be and how maintenance intervals and who pays for things when they're specified on a maintenance interval. So that's current regulatory work that's ongoing at the agency with some workshops that we've been holding. We also recognize that beyond just OEM responsibility for initially providing good product and supporting it. There is, user responsibility as well. And so our current, the thing that's closest to that is our smoke opacity programs. But they were designed a couple of decades ago for mechanically injected engines, and so the cut points need some updating to be anywhere near relevant for DPF class vehicles. So we're looking to do that as a pretty quick stopgap measure on our way to doing a more expansive multi-pollutant inspection maintenance program. And so we want to have some kind of program that checks that the vehicles are operating properly, but we recognize that as these systems become more efficient, the inventory gets driven by the high emission tail, the couple of vehicles that have a real problem. And so how do we have a screening program that doesn't burden all of the vehicles that are operating properly while you're looking for these couple needles in the haystack that are driving the inventory? So we were very excited about the developments that are going on with, we see that every OEM has some kind of telematics package for fleet management and remote OBD and whatnot. And what are the ways we can use some of those kind of communications technologies combined with the advancing heavy-duty onboard diagnostics to have a remote compliance option that is fairly invisible to all the vehicles that are operating properly, but then there's encouragement to make sure that the few that are having issues get repaired. So we have a pretty ambitious rulemaking calendar with some of these small things like the smoke opacity program coming pretty early. The warranty discussion has gotten a little more detailed than we were initially anticipating, so that one will probably slide a little bit. And then the bulk of the NOx standards and in-use compliance things are coming in 2019 with an inspection maintenance program the year after that. Well, I talked quite a bit about our low NOx and regulatory issues that we're working on to do the traditional combustion technologies, but we're also interested in where can the alternative technologies get some traction and where might they make sense and whatnot. And so we have some discussions afoot of how to get what's the right kind of flexibilities to accelerate this kind of market, and we're leaning towards some kind of a bankable, tradable production mandate sort of way to do it, so that manufacturers can figure out what makes sense for them and customers can get the vehicles that make sense for them, but the applications where they do make sense can stimulate some production and start building supply chains and that kind of thing. So it's a concept we're actively workshopping and talking to people about, and if you have great ideas or interests or whatnot, we're happy to hear about that. So that's kind of the stick, but we also are working the carrot side, where I mentioned a little bit about advanced technology demonstrations. We're funding pre-production or pre-commercial demonstrations of freight vehicles and yard dog trucks and electric buses and fuel cell transit vehicles and all kinds of things in this early technology, trying to support the development and early demonstration as well as piloting of these technologies. We also have, for commercialized technology, we have our HVIT program, which started out as the hybrid voucher incentive program, and now it's the hybrid electric zero-emission truck bus. The name's gotten real long, and we kept the HVIP acronym, but it applies to batteries and fuel cells and hybrids. Purchase and voucher, trying to cover incremental cost for those kind of vehicles. And then we have use that same structure to support low NOx engine purchases as well. So all these funding efforts go through our annual public process to come up with the funding plan. And then recently we've also gotten some Volkswagen NOx mitigation funds that'll be going through a similar process. So we're trying to support the development side of these and the supply chain and whatnot. So aside from, I've talked quite a bit about, what we're doing and what we're trying to see accomplished and whatnot, but this last slide is kind of a, things that were interesting to Bill in this zero emissions area. And, there's the observation that all of the big suppliers to the U.S. bus market have a zero emission options. A couple of them, that's all they do. There's in the last couple of weeks, 12 big cities came out and said, hey, we're going to agree to buy only zero emission buses after 2025. So that's 100% penetration in a particular sort of application. And in LA, the LA Metro, they run 2,000 buses. They're committing to go full electric, not just go to electric purchases at 2025, but to go full fleet turnover by 2030. And so then there's mention of some of these companies like Tesla that are getting into the market that have been doing other things like light duty, and BYD's been in the transit side, but each of these have announced their zero emission truck programs and are actively working that direction. And then we were looking at the breakdown of who are big players in the traditional field, and we see a number of those making moves in this space to make sure they're positioned and getting some experience and getting some customer experience with these vehicles from Daimler and Navistar and Cummins and those kinds of places. And I put it last, but kind of the one that I'm most interested in is not the initial sort of exploration kind of things, but the user pull, the pull forward from the market. And DHL has been doing some very interesting things in the zero emission space. They've mostly been over in Europe, but they have 3,000 of these little, or 3,400, something like that, these in-house produced little delivery vehicles that are full electric, and they form partnerships with Ford and with other people. They have 2 or 3 different platforms they're actively producing, and this is like the post office or something, right? I mean, this is Deutsche Post. These aren't Tesla type organizations in the conservatism thing. So it's interesting to see that interplay between the business environment they're in and making some of these bets. And my understanding is they have about 20,000 vehicles in their fleet. So 3,000 is a pretty significant investment to be making there.
It's a small company funded by a professor in Aachen to develop this car, and it's now rolled out.
And they're willing to provide it to other people and whatnot. So I mean, it's
they have a partnership with Ford in Cologne using transit chassis for the bigger cars. It's a one-seater just for the purpose of delivering of parcels and letters.
So it's very interesting to see a company that's saying, I have a specific vehicle I need for my business purpose, and going out and getting it, and it happens to be a zero emission is what they're settling on. So anyway, so we have large challenges in California, both to meet our climate goals. Tim was showing that phase 2 justification graph, and if you look at what we need to do to hit our 2030 and 2050 goals, right about the time it starts picking back up with population growth or economic activity, we need to keep going straight down at that point for another 20 years. So we continue to work very hard on this and seek partnership, locally within California and internationally, and as well as working with our colleagues at the federal level. We're very active in trying to keep them informed about what we're doing and what we're seeing, and discuss with them what can have national merit. Because there's a lot of the Class 8 truck that drives the trucking market. There's a lot of those trucks in California that were bought new outside of California and sold into the secondary market. There's a lot of trucks that just pick up a load outside of California and drive in. So the national solutions we recognize the importance of that. But it's a very exciting time with available technologies for the conventional diesel approach, as well as these advanced technologies, and we're trying to make a strong investment in them. So there's some contact information, and thank you for your attention.
Thanks, Bill. Thanks, Bill. So very interesting to hear what progress you've made. Even since last year, the update is quite dramatic in terms of the work you've been doing. We appreciate that. We have time for a question or two before we break, so let's have some questions. Ben, we have a microphone. Please introduce yourself and your company before you ask the question. Thank you.
Good morning, and thanks, Bill. My company is ICCT. My name is Francisco Posada. My question is, well, first of all, very interesting presentation. It's really interesting data on NOx emissions from those buses and trucks that you tested. My question is, has the MFAC model, has it been updated with these emission factors from these tests? And what would be the connection with the inventory data that you presented that requires 70% NOx reduction by 2023? So the question would be, if the MFAC has been updated, and what do you expect to be the impact in terms of the inventory if once the correction is being done?
So, the upfront caveat is that I'm a vehicle testing guy, not an inventory modeler. So, take it with a grain of salt. So we're currently working on the MFAC 2017 update. Every scrap of data we generate or hear about, we vacuum up and goes into that process. The Truck and Engine Manufacturers Association, was in discussions with us about some chassis testing we'd done initially on the early SCR vehicles, and they, ponied up to provide testing and vehicle procurement, and even shared those vehicles with our lab. So, there's a lot of activity going on in that 2017 update. I mean, I realize we're in November here, so, we'll see if they get it out in 2017, but we're working on that. And, I'm not sure exactly how to specifically answer the question as to which category is going to shift how much, because these were vehicles across a whole bunch of size categories, and all the normal caveats of fleet mix and whatnot. So we're working on it.
It does sound like the higher than expected emissions could result in needing a bigger cut, ultimately a higher percentage reduction to achieve the air quality requirements. Or is that too much of a generalization?
There's always, interesting in these discussions of, what do you think is actually happening in the real world versus, what is reflected in the model that you have data to populate and resources to support the complexity of of things. So I think some of these types of increases are things we're looking for to correct on the current product, and then we'll probably need similar amounts of reduction to get where we're going. But exactly how that plays out, we're in discussion to figure out, make sure we understand what these effects are and how general they are in the population. So it's work ongoing, but I was trying to present some of these things where they're both sort of small snapshots that we've looked at, and they look like they bear further investigation, and so we're actively involved in recruiting vehicles and discussing with the fleets and with the manufacturers, trying to understand what's happening on a mechanistic level that you don't get just looking at a tailpipe rate.
Good. Any further questions?
Tim Johnson with Corning. Thanks a lot, Bill. Question regarding cold start. There's a 1 in 7 factor that's used in the FTP, if I remember correctly. You showed data that warm and cold starts might be a little bit higher than that. I estimate 20 from your chart. First of all, what was the definition of warm and hot start in your chart? And do you think cold start needs a higher weighting?
I think weighting factors are definitely something that's in our consideration of the what the next standard should be. My understanding is the way the bar in the chart. I don't know if we can sneak back there. Was they were looking at sort of what the running rates were for the emission factor once the engine's operating, and then you can take an emission trace that with the vehicle starting and lay it over that, kind of slice off the amount of emissions that were attributable to what the engine would be doing once it's warmed up, and what's the area under the curve of that bump that's exceeding that. And so they're doing that kind of analysis for cold start and for varying length soak time before a rekey event of a partially warmed vehicle. And so that that's one of the areas that's going to change in IMFAC 2017 is a much more detailed treatment of those restart rekey events. So whether you call it hot start or warm start or whatnot, but it's that excess emissions due to a keying event that's clearly dependent on how long the vehicle's been sitting previous to that.
Bill, can I ask a question? In the absence of Charles, can you comment on what you've seen as the most promising technology work they've done in terms of the ultra-low NOx and the approaches that you think offer the most promise in terms of a conventional engine after treatment architecture?
Well, Mika really stepped up, and they came forward with a bunch of teams that each proposed equipment and brought prototype things, and all the way you could remix the individual pieces that were brought. There was 200 or 250 different sort of architectures that were looked at least on a engineering analysis basis, and about 30 of those were then taken to a transient burner rig that would give you could do multiple cold starts in a day instead of having to wait for this big chunk of iron to cool back down. So there was this screening of, so it had temperature and chemical composition and flow rate and controlled. And so they went through about 30 of those configurations, and about 5 of those advanced to engine testing. And so there's a lot of diversity of stuff looked at, and I don't have the slide in this particular presentation, but it's available on our website. The final report from stage 1 looks at those different configurations. There was, putting a piece of SCR up in the front with its own dosing so that you could dose that early, and then later on, once the rest of the system warmed up, you could dose down by a big chunk. And there was passive NOx absorbers to try and catch the NOx and hold it until you could get the rest of the system warmed up, and then it bleeds through once the system can treat it. And the very promising technology looked like around thermal management, and how do you not have a cold brick that you have to heat up before the brick you need to use gets warm. And so the SCR coated onto DPF, the SCRF technologies, looked much more promising than the conventional DOC, DPF, SCR type technologies. And so then it came down to sort of what exactly is the exhaust profile and how quickly do things need to get warmed up. But the configuration that we put through the most rigorous on-engine aging procedure was a passive NOx absorber that has some DOC function, and then a mini burner to be able to dump in heat very quickly, and then it was an SCRF with a piece of SCR backup, and that was what we did the demonstration on within the time and budget constraints of our program. Some of the things that we didn't have as much time to play with the calibration are some of these dual point dosing strategies, where you might think about having a little bit of pre-SCR somewhere that can be dosed, but you can't dose all the urea there because it would get oxidized by a DOC or something. So there's clearly a lot of area to explore, and in the stage 3 we're interested in, can we reduce the complexity of the system? Is there a way we can get to these kind of levels, but not necessarily, a burner has an air system and an ignition system and a fuel system and sensors, and and then it's hot, and then the exhaust, the thermal cycling, and it's being run much more than a regeneration type burner that have been used in various applications. So, there are reasons to assess that technology as to, how does it fare against other options. And so,
it sounds like there were several options that would likely achieve the low NOx requirements.
Right. I mean, the particular one we got was like, well, we're running short on time and budget, and this is the one that'll get us over the line to demonstrate that it's not impossible. But we clearly don't have a lock on creativity, and we hadn't run out of ideas at that point.
Any final questions for Bill? I've just got one final question then, Bill. In fact, that chart you show, which is the build-up of the NOx inventory, do you think there's any role in there, or have you seen any evidence of tampering as being an issue? Is that factored into deterioration, or is tampering just not happening?
In our inventory, we have these TM and M rates, tampering, malmaintenance, and malfunction, and so it's all of those are represented in that deterioration. What I call deterioration, just for quick recognition on the chart. There's probably some of that that's happening. Getting real hard numbers on the rates is a little tricky at this point. I think OBD is starting to sort of, you have to be more determined to do it at this point, going forward. Although we don't have a lock on creativity, as I mentioned earlier. So, I don't think we have quite as big a problems as some of the reports out of like Eastern Europe of everybody putting blank off plates for their EGR and that kind of thing. But it's definitely something we pay attention to, and we have field inspectors, and it's an issue we're trying to get our arms around.
Excellent. I think that's been super informative. So thank you, Bill, for taking the time to run us through that and answer the questions. Thank you.